Okay, so we did our first one and we found that at 0%, it was at zero percent concentration, it was 96% transmittance. Okay, so then we come back up here and we're going to do the same thing again, but we're going to have to change. And this may have been something that tripped some people up. You're going to have to change your concentration from 0 to 10%. And then you're going to play the same and do the same thing again. So you want to have your tools out with you, ready to go. And like I said, I just like to, well, that one, keep saying that one's not very useful, but I go ahead and open up the other three and just put them down here, or somewhere there. All right, then you're going to hit play, and we're waiting on the yellow to pass through the cuvette. So there's blue, aqua, green, and yellow. And we're going to need to back it up because I went too far. Okay, so now this is the dot I'm looking at. So I'm going to try and line up and see what percent transmittance is going to match up the best here. Stop. And what's up? 94 is the best. So 10%, I have 94% transmittance. Okay, so now I'm going to come back. I'm going to skip the 20% because my table doesn't have a 20%. It has a 30%. So I'm just going to leave that row in my table blank, and not worry about that. So here we go, here we go, here we go, here we go. Stop. Back up. And there it is, right there. Okay. So now I'm looking for that gray spot right there. So I think this may be too light. Yeah, I think this one's too light. So let's try this one. It's a little aggravating. I think that probably does it. 76. So 30%, like I said, I'm skipping that one. 76. And again to 40%, hit load. And hit play. And stop. Back it up again. A little bit more. There we go. All right, so here's my gray spot that I need to find and see where we're at with that. And that looks pretty good, 69%. So at 40%, I got 69% transmittance. And then we got one more to do. 50, load. Same thing again. Hit play. And stop. Okay, let's move through just a smidge. Okay, so here's this one. I think this scale is now too light. Yeah, so that one's too light. So let's try this one. That's probably too dark. Oh, that's good. 56%. Okay, so I have my data. Now, what I'm going to do is I'm going to, and this is what they're talking about in the calculated column, I'm going to change it so that this column is going to give me the percent absorbance. And I'm going to use the formula that is in the background information. So it's negative log times the transmittance divided by 100. Divided by 100. Oh, really? Ugh, clear. Okay, negative log the transmittance divided by 100. Oh. Unfortunately, you cannot back up on this thing. So, got to get it right the first time. Negative log transmittance divided by 100. Close the parentheses, submit. Okay, so now what it did is now it took this value and just plugged that in and calculated the absorbance for me. And down here on the graph, what I'm going to do is I'm going to plot the concentration versus absorbance. So here, I'm going to choose absorbance, and okay, I'm going to leave that there. All right, and then, so I get this is my scatter plot. Now I need to get a curve fit, and I want my line of best fit to be linear. So I'm going to draw a line of best fit in there, and that's my line. And then right here, I'm going to click this display curve fit uncertainties. That's going to give me my R value, which I want. This R value here is going to tell me how close to a straight line this actually comes. And it's pretty close. It needs to be close to 1. And it kind of is. So, and here's the equation of the straight line, y equals ax plus b, same thing, where a is my slope, b is my y-intercept, okay? All right, so then you're going to use that information to answer your question number 2, and you're going to use, when it says use linear regression tools, what that means is you're basically going to take your mouse and you're going to hover over 45%. You're going to hover over halfway in between 45 or 40 and 50. Okay, so there's 45.9, there's 44.8. That's probably about as close as you're going to get it. And you can see from that your absorbance value is going to be 0.202. And so then you're going to come down here and choose the thing closest to 0.202, which is going to be this one right here. And you're going to click submit. Okay, and then you'll lock your answers and move on to the third part. So on the third part, what you're going to need to do then is we're going to do the same basic thing, but we're going to throw in that time factor with it. So go ahead and let's see, I'll go ahead and get my tools out and move them off to the side here. Because again, you're going to be doing the same thing that you did before. But this time we're going to time it. Okay, so as soon as you, let's see, let's go by the directions here. The cuvette is placed in front of the yellow ID. Use the transmittance tools in the upper right-hand corner to measure the transmission as a function of time as the reaction progresses. Use this graph and table to graph your data. Remember to zero your stopwatch the first time you can accurately measure transmittance. So when we hit start, what's going to happen is this dot is going to change colors. And when you first see a change in the color, then you're going to hit stop, and you're going to hit the stop on your timer, okay? To zero your timer, and then you're going to measure your transmittance. Okay, so we need our timer out. Oops, we need our timer out. And this can move in the corner, which that's much better. Okay, so we're going to hit these at the same time or as soon as possible. Oh, no, not now. Sorry. I shouldn't have done that. Let's start over. Close that. Come on down here. Come on. Move down. There we go. Okay. So I'm gonna have to. Okay, so we're gonna hit. Yeah, we're gonna hit play. We're gonna watch when we see a change in this color of this dot. No. Yeah. Go ahead. Okay. All right. So then we're going to set this to 0. And then we're going to measure our percent transmittance. Um, there. That looks about right. So at time 0, we have 58%. Okay. All right. And then we're going to hit play, and this is going to start again. And when we see a color, when we see this dot change a second time, then we'll hit stop. We'll stop it. Okay, so we can see now that we've got, this is definitely going lighter. So we went ahead and I stopped it at 12:23. And yeah, that's still lighter. Let's see, that's still, okay, that looks better. Let's try. There, 64%. Okay, and then I'm going to hit play again and watch this dot, same dot, change again. And definitely distinctively lighter there at 21.97. So let's try to find a good match. That looks like a good one. Maybe a little bit lighter. Yeah. All right. So at 21.97, it's 71%. And then hit play again. Well, why is it not playing? Huh. Well, that's interesting. Okay, 21.97. Oh goodness, I don't want to start this over. Okay, I'm just normally you would continue on and get 5 more points. I'm not going to because I don't want to have to start this all over again. And for some reason, I'm afraid it's just not. just not going. Yeah, I was afraid it was going to do that. All right, so we're just going to graph using these 3 points. Won't be the best graph in the world, but it'll be okay. Um, so you have 2 other columns here. We want to do the same thing with this absorbance column that we did in the previous table, where we're going to go to change column formula, and we're going to put in that absorbance is equal to the negative log of the transmittance divided by 100, and then in that parentheses. So that's going to give us those. This last column, since we're trying to find rate, well, let's do it this way. Let's put absorbance here and see what kind of, well, it's difficult to see. Oh, you can very easily see what kind of graph I'm getting here. So let's put in our curve fit, linear. Okay. So you could do absorbance versus time. And if we plot that graph, we do get a -1 for our R value. We could also, since we're looking at rate, we could also plot the no, not negative, the log of absorbance. There. Yeah. And we can change the column name. This would be the natural log of absorbance. Okay. We could also change this to B, where we plot the natural log of absorbance. And you can see that if we plot log of absorbance versus time, we get, and we do curve fit again to get a linear curve. Yeah. If we get a negative slope on that, then that would mean that this would be a first order reaction. If we plotted absorbance versus time and got a negative slope, it'd be a 0 order reaction, and so on. Now, I'm not going to get very good data because I only have 3 points here. So you need to make sure that you go ahead and do that for 2 more trials. Like I said, my graph is messing up and I don't want to have to start this over a 3rd time. So then you're just going to use that data to answer question 2, answer question 3. Now let's figure out the order of the rate law. To review, here are the 3 rate laws. So 0 order would be that formula. First order is this formula, or natural log. And we use the natural log version of it that's in your reference sheet. And that's the same thing as this, really. Second order would be the 1 over the concentration. So using the last column of the data table, try to linearize the data according to the rate laws above and figure out which is the best fit. So you would use this. You can add a column here too if you wanted to. Yeah, we could do another column to the right and try and do 1 over the concentration of, and plot that versus time, or 1 over the absorbance and plot that versus time. Yeah, if you wanted to, but you don't have to. But that's what those are for. So you would want to try and plot each 3 of these: absorbance versus time, log of absorbance versus time, and 1 over the absorbance versus time, and see which one gives you the best linear fit, gives you the best straight line with a negative slope, and then that is going to determine your order. Okay. I believe this reaction is first order. And let's see. Heads up, you need to submit it. So yeah, it's a first order reaction. So make sure you plot the log first of absorbance versus time. And then for using the reaction order, what is the value of M in the rate law formula below? So it should be a 1, I'm guessing, because if this is a first order reaction, then each of these would be raised to that would be raised to the first power. Yeah. Okay. All right. So I just wanted to make sure you understood how to plot these graphs, because since there was a lot of confusion with that, um, and how they got those numbers, how they got the transmittance, how they got the absorbance, how you calculated that you didn't have to calculate it. You just needed to put that formula in your table, and it will calculate it for you. So, and they got that all the way back from Beer's law, which is using this formula here. Okay. All right. So I hope this was helpful for Crystal Violet.